Today, we are finding out who and how many other people like a post on social media, comparing a number in one array with its square in another array, and then we take a deep dive into the wonderful world of dependency injection. Hello world, and welcome to episode number 10 of Versus Codewars. We begin today with something you may have seen on Facebook quite some time ago. Given an array of strings, our goal is to return a display text that shows who and how many other people like a post on social media. Our return strings should be something like these examples here. Given these arrays, we should return something like these, as you can see here. Alright, let's go ahead and get started with this. Alright, we need to get the length of our names array. So const count equals names dot length. And what we'll go ahead and do here, we're going to do a little switch statement here. Switch count. In our default case, anyway, our case 0, we're going to go ahead and return no one likes this. In case 1, we're going to do return a template literal that does this. Names at 0 likes this. Case 2, if we have 2 people liking a post, we're going to go ahead and return names at 0 and names at 1 like this. Case 3, if we have 3 people liking a post, what we're going to go ahead and do is names at 0, names at 1, and names at 2 like this. And in our default case, if we have more than 3 people liking the post, what we'll go ahead and do is return names at 0, names at 1, and names dot slice at 2 dot length, or rather count minus 2 others like this. Alright, we're gonna go ahead and feed this into node who likes it. In the case of our array here of 4 different names, we should get Alex and Jacob and 2 others like this. Alright, let's go ahead and feed this into Codewars and see what that looks like. Let's try submitting it. And we are good. Time now for the better solution of the day. Pay attention to this code block that you see before me. The one thing that makes this better than what I submitted is the OR conditional you see just above the switch statement. It's always a good idea to null check and type check and possibly value check what is passed in to your functions in JavaScript just to make sure the right stuff is being passed in. Here is a function that takes 2 arrays of numbers. Our goal here is to check to see if the square of each element in the first array is present and occurs as frequently in the second array. We are writing a function that checks to see whether the 2 arrays have the same elements with the same multiplicities. Let's go ahead and get started here. First of all, it's not guaranteed that the arrays given will be in any sorted order. Let's go ahead and remediate that first. What we'll go ahead and do is we'll take first equals first dot sort, and we'll do the same with second equals second dot sort. Or rather, what we'll go ahead and do, we actually need to type check this first. It's always a good idea to type check what you pass into functions. We need to make sure we have arrays here. First equals here. First array dot is array first, and then first dot sort, or just an empty array. Second equals array dot is array second dot sorts, or a blank array. Do a little bit of a sanity check here first. If first dot length is 0, or second dot length is 0, we'll return false. And if first dot length is not equal to second dot length, return false. Alright, we're going to go ahead and console.log our sorted arrays and see what they look like. First, second. Feed that in nodes. Are they the same? And we do not have our arrays sorted here. Okay, what we'll go ahead and try here is we'll try passing predicate functions into our sorting, our sort calls here. Let's see what that looks like. Alright, now our number should be in sorted order. Now it should probably go to say that yeah, our numbers here are in sorted order. What we can now go ahead and do is return first.every. We'll go ahead and pass our predicate, our element, into our predicate function as well as the index. And we'll return true if element times element is equal to second at index. Because these arrays are now sorted, these should be parallel. Alright, let's feed this in a node to see what that looks like. And note that we have true here. Let's go ahead and feed this into Codewars and see what this looks like. And let's try submitting this. And we have a problem. Alright, what seems to be the problem? Expected true, got false. Let's go ahead and console.log our first and second arrays here. And run that through the Kata. And the test is failing because it's being given two empty arrays. So maybe we need to return true here. Let's go ahead and try feeding this into Codewars. Without the console.log here. Now what's the problem? Maybe the null checking. Maybe the null checking is the problem here.
try running this console log above our null check here.
Alright, what we'll go ahead and do here is first or second return false. Run that through the Kata here. Coming out this console.log here. And let's try this again. And we are good. On the subject of checking the arguments that you pass into a JavaScript function, it's generally a good idea to follow this order of checking. First, you null check the arguments to make sure that something is being passed in. Then, you type check the arguments to make sure that the correct type is being passed in. Something you don't need to worry about in strictly typed languages like C++ or TypeScript. And then you validate those arguments, checking to see if the correct values are being passed in. For instance, check to see if x is between 5 and 15. Also in this kata, you saw the use of the array object's every method, which takes a predicate function and returns true if that predicate function returns true for all elements in the array. A similar method in the array object is the sum method, which returns true if the predicate function returns true for only at least one element in the array. Here is an implementation of a dependency injector. The class seen here is constructed with an object containing data upon which a function injected with this inject method will depend upon. I have a sample dependency injector right here with two dependencies, both functions which return strings. I inject a sample function with its inject method taking two arguments, their names corresponding to the keys in the dependency's object. I then run this injected function right here to see what happens. Let's go ahead and try implementing this. Alright, the goal here is to implement this inject function right here. This is going to return a function that will go ahead and run this function with arguments specified by our dependencies object supplied by the constructor. Alright, first what I think we need to do is we have to try to get the names of the arguments supplied by the function. What I'm going to go ahead and do first is console.log the string form of this function. Console.log func.toString. Feeding it into Node. We see that the string form of the function right here. The goal first is to get the names of these arguments right here. So what we're going to go ahead and do, I'm going to comment this out for a second here. Alright, we're going to go ahead and store the string form of this function into a variable. Const func_string equals func.toString. What we need to do is get the index of the first opening and then the first closing parentheses of our function. And we do that by doing this. Const open, call it param start equals func_string dot index of the opening parentheses, and const param end equals func_string dot index of the closing parentheses starting from param start. Alright, we're going to go ahead and console.log those and see what those look like. Console.log param start param end. Feed that in the node. And it gives us the positions of the opening parentheses that starts our function's parameters and the closing parentheses that ends the function's parameters. What we need to do from here, we got to get the substring between those 2 points to get our arguments. Const param substring equals funcstring dot substring param start param end. We're going to console.log that and see what that looks like. Maybe start from param start plus 1. Whoops. Numlock. And we should have the list of our arguments separated by a comma. Alright, what we're going to try to do here, we're going to try to split this with a comma. We're going to do const params equals param substring dot split with a comma. We're going to run console.log that and see what that looks like. And we are going to need to trim spaces out. So .map param dot trim. And that should get rid of any of the trailing white spaces, and we should now have our array dependencies. But there are some ways that this can be thrown off. And we can make that pretty apparent by doing this. Setting a default parameter in one of the arguments of the function we are injecting. Let's speed that into Node and see what that looks like. Here, as you can see, our split ends up catching the default parameter. We do not want that. So what we're going to go ahead and do is split each parameter with an equal sign. Get the first element of the resulting array. We can actually go ahead and optimize this by doing this. Param.split with the equal sign. Get the first element and then trim that. Now, as you can see, we get our arguments without any default parameters. There is, however, yet another way that this can be tripped up. What if we did this? Inserted a comment just after the first parameter. Unfortunately, the function string ends up catching the comment as well. So what we're going to need to go ahead and do, we're going to need to use a regular expression to get rid of this. So what we're going to need to end up doing is we're going to need to use a regular expression to get rid of these comment signatures. So, and we're going to need to figure that out. We're going to go ahead and create a regular expression here. Const comment regex. This needs to catch the double dashes or the /star comments. We can go ahead and catch the double dashes with / forward / forward /, and then anything after that. Or what we can go ahead and do is / ****. This dot character class should capture anything, any kind of character. We're going to catch multiples of those with the plus sign. And then ****, ****, forward /. I think this should catch any kind of comment here. Let's go ahead and test this out here. We're going to append our substring return here with .replace comment regex with a blank string. Let's speed this in the node and see what that potentially looks like. And as you can see, we successfully filtered out our comment here, and we have, again, just our argument names. I think another test case we should try out just working out any potential edge cases that could trip our inject method up. Oh, that could potentially trip it up too. What if we had a default argument that had parentheses as part of an equation here? That will definitely trip us up as well. So what we need to go ahead and do, we actually need to subject our argument string to a valid parentheses sequence. You may recall me doing a kata some time ago. You may remember me doing a kata some time ago of me determining if a string had a valid sequence of parentheses. What we can go ahead and do is alright, I'm going to go ahead and comment this out here. Alright, I'm gonna go ahead and change the name of this function here. Const yeah, actually I'm gonna leave that the same. Alright. Yeah, we're gonna need like the what we're going to go ahead and do here, we're going to clean this up a little bit. We're going to need the position of either the function start sequence of an arrow function or the opening brackets that begins the function body. Let start function body index equals func string dot index of. We're first going to go ahead and look for the equal sign greater than sign start function signature that begins the that comes just before the beginning of the body of an arrow function. What we're going to go ahead and do here is start if start function body index is -1, we're instead going to go ahead and look for the position of the opening bracket that indicates the start of the function's body. Func string dot index of the opening bracket. What we're going to go ahead and do here, we're going to get a substring that goes from the position of the first parentheses that it finds. And we're going to go to the position of whichever these two index of methods finds. So what we'll go ahead and do is const param end equals func string dot substring param start +1 to start function body index. We're going to go ahead and console.log that and see what that looks like. I'm actually going to go ahead and rename this param string. Console.log that and see what that looks like. There's got to be some kind of reverse find here. Alright, from here we're actually going to need to find the position of the last... I just thought of another issue here. In the case of arrow functions, particularly arrow functions with no parameter, a single parameter, excuse me, these parentheses actually are not needed. I actually need to account for this. So I'm going to give this another try here. First, we're going to go ahead and get the func string as usual. Func toString. We're still going to go ahead and get the position of the function start indicator, either the arrow signature or the opening brackets. Const func body start, or rather let func body start equals func string dot index of the arrow func body start equals func body start -1 or func string dot index of the opening brackets. Alright, we're going to go ahead and console.log that and see what that looks like. This is actually not supposed to return a Boolean. So we'll do a ternary operator here. It should give us the position of the function start signature whether we're using an arrow function or the standard function syntax. I'm going to take a substring of that. Const, or rather, let func param body param string equals func string dot substring slice from 0 to func body start. We're going to go ahead and console.log that and see what that looks like. And we should have our arguments right here. We're going to go ahead and trim that to get rid of any white space. Alright, what we need to do now is run this through a function that determines a valid sequence of parentheses. And what we want to return out of that is the position of the first parentheses in the sequence and the final closing parentheses of the sequence. So what we're going to go ahead and do here, we're going to rename this helper function here, get parent sequence positions or rather, there might be an easier way to do that. If I'm not mistaken, doesn't trim left and trim right take an optional parameter? Let's see here. Trim left. Is that legal? Let's try it. No, that doesn't work. Doesn't that like take an optional parameter? Alright, let's try this. Now replace using a regular expression at the start of the string, the opening parentheses, or at the end of the string, a closing parentheses. We'll replace that with a blank string. Let's see what that looks like. Yep, that does successfully get rid of the opening and closing parentheses. So we're on to something here. So we're taking this function string, slicing to the function body start signature to get our parameter string, trimming any white space, and then replacing the using a regular expression to replace the opening and closing parentheses of that parameter body with a regular expression with a blank string. And that leaves us with our parameter body with the default parameters, by the way. And what we need to do from here is get rid of any comment signatures with our comment regex and replacing those with empty strings as well. Let's try tripping this up again with a comment. As you can see, this also trips up our function here. We also need to get rid of any new line characters in here as well. So let's create a new regular expression here. New line regex equals. We're going to go ahead and get rid of any new line and carriage return characters here. And we want to replace those with empty strings as well. So what we're going to go ahead and do here is not replace new line regex with a blank string. Let's try seeing what that looks like here. Now we need to get rid of any tabs as well. We'll just stick this in our new line regex as well. Nope, that ain't gonna do. Maybe white space? Yep, that'll do. And as you can see, this comment here is no longer tripping up our parameter logic here in our inject function. So now what we can go ahead and do is finally get our parameters, and we can do that by doing this: const params equals func param string dot split with our comma, and then we need to account for default parameters by getting rid of this equals signature here. Dot map param dot split with the equal sign, getting the first element. We're gonna go ahead and console.log that and see what that looks like. And as you can see now, we now have an array of the names of our parameters. That was a little bit of a heavy lift right there, but now we can continue with what we're going to go ahead and do. And what we're going to go ahead and do is, in our return function here, we can iterate over our dependencies, or rather our params here, map them out to our dependencies that we supplied in the dependency injector, What we can go ahead and do here is iterate over these parameters, map them out to dependencies supplied to our dependency injector through its constructor, and then we can call the function that we pass in to inject with these dependencies as arguments. So what we'll go ahead and do is const needed dependencies equals params.map param as in this and dot dependencies. This, by the way, is made possible by the fact that we are returning an arrow function which does not have its own this context like the normal function syntax has. Anyway, at this dot dependencies at param. And then I think we need to filter out any of these that return undefined. Dot filter value equals type of value is not undefined. And then from there, we should have an array of the values of our dependencies. What we can go ahead and do from there I have an idea. Okay. I might put that on the back burner for a second. What we'll go ahead and do from here, we're going to go ahead and call our injected function, the function that we injected into this dependency injector, and we'll use the spread operator with our needed dependencies to pass in each dependency as an argument to this function. Alright, we're going to go ahead and feed this into Node, see what that looks like here. Nothing happens. Of course, nothing is supposed to happen because yeah, maybe we tried console.logging these first. As you can see, it prints the return value of the first dependency here, which is the second argument in the injected function. And then it prints the return value of second dependency, or rather, dependency, which was the first argument of our injected function. Let's run some test cases here. I look forward to seeing what we can do with this. Set A to 3. I expect to see 15 here. We're going to go ahead and console.log the return of this. Undefined.
Alright, what's going on here? We're gonna go ahead and console.log our needed dependencies. We have our 3 and 5 here.
Maybe we would need to return this. Yep. And we have our 15 right here. Let's see what some of these tests here look like. Let's go ahead and take this list of dependency functions here. Pass this into our dependency injector. And try injecting this function in. Let's run that into Node and see what that looks like. Dep2 is not a function.
Of course it's a function.
Alright, let's go ahead and console.log our dependencies and can see what's going wrong here.
Dep1, Dep2. Seems like there's something wrong with our argument parsing logic here. Console.log of param string and params.
That might not have been the best way to go here. Alright, what we're going to go ahead and do here, we are going to need the position of the opening parentheses that starts our arguments. Const func params start equals func string dot index of that opening parentheses, or rather let. Oh wait, maybe const. Instead of 0 here in our slice, we're going to do func params start. That seems to have worked. We now have our dep3, dep1, and dep2. It's calling the function correctly, returning this is dep1, this is dep2, this is dep3, joined together by an arrow. I think we are finished. With this. Let's go ahead and comment these console.logs out. Whoops. Comment these console.logs out. Run this again. I think we're done here. Let's go ahead and try feeding this into Codewars. I don't know if the Kata will accept the use of our class here. Let's give it a try. And try to submit it. And we are good. The JavaScript function's arguments object may be a good way to get the values of the arguments passed into a function, but it does not get you the names of the arguments that you pass in. What you find in between the parentheses inside of a function signature, the only way to get that is to get the string representation of that function using function.toString, and then a clever use of regular expressions and the string objects trim, split, slice, index of, and replace method in order to account for any comments embedded into the parameter string and default arguments. Also, what you saw in the return function of the inject method was an arrow function that does not use its own this context. This allowed us to use the list context of its parent scope, which is the Dependency Injector class. If I used the regular function syntax, I would not have been able to do that without setting a variable to the this context of the Dependency Injector class and then exposing that in the return function. And that is going to do it for this episode of Versus Codewars. If you like this video or you learned something new, drop a like and subscribe to this channel to see me take on more challenges from Codewars. As always, if you think there's anything I can do to improve on my code, feel free to drop a suggestion in the comments section below. I hope you have a wonderful day, and I will see you on the next episode of Versus Codewars.